parent borrows at X at an annual effective rate of 5% if the principal and all accumulated interest is paid in one lump sum at the end of 20 years. 1,000 more in interest would be paid than if the loan was repaid with level payments at the end of each of the first 10 years. So we should be calculating the interest paid in each option, and the difference of those two interests is 1,000, and that should help us calculate X. So let's see. The first option is the usual compound interest formula that we learned long ago, because that's what happens if you pay the principal and all interest in one lump sum. You're just paying an amount based on the compound interest formula. So interest rate is 5%, and it's 20 years. So therefore, in this case, the amount paid would be X times, remember the principal is X. So A is equal to principal times 1 plus the interest rate power the time. That's the basic compound interest formula. And the 1.05 power 20 simplifies to 2.6533. So that's the total amount paid. And since the loan was X, so this total amount consists of the loan amount plus the interest. So if we just want to calculate how much interest was paid in this case, it would be the amount minus the loan amount, be A minus X. And that's 2.6533 minus X. That's 1.6533X. So in the second option, she pays level payments at the so 1,000 more in interest if it would paid than if the loan was repaid with level payments at the end of each of the first 10 years. So basically the second option consists of 10 level payments, and that's annuity immediate because the payments are happening at the end of each of the years. So for a 10-year annuity immediate, with the loan amount being X, loan amount, remember, serves as the present value. So in this case, the present value, which is X, will equal each payment. Let's say each payment is P. Let's say each of the level payment is P. Then X will be equal to P times 1 minus 1 plus I power negative N. So N is 10 because there are 10 payments divided by I. So this quantity after the P reduces to 7.7217. And if we solve this equation for P by dividing by 7.7217, we get P equals 0.1295x. So that's each payment. Remember, P is each of the level payments, and there are 10 of them. So the total amount that she pays in the second case will be 10 times the P, which would be 10 times 0.1295x, so 1.295x. And once again, the interest paid in the second option will be the total amount paid in these 10 payments minus the loan amount. And so it would be B minus X, and B is 1.295x, and loan amount was X, and the difference would be 0.295x. And now we are given that the difference between the two interest amounts is 1,000. So I1 is the first interest amount, which came out to be 1.6533x, and the second one, I2, was 0.295x. So the difference of those two is 1,000. I1 minus I2 is 1,000. So we substitute what I1 and I2 were. And this gives us 1.3583x equals 1,000. We divide by 1.3583 to get x equals 736. That was choice D.